Hello and welcome to this video on waves. Specifically today we're going to start talking about terminology so that when we talk about waves and do experiments with waves going forward, we can use the appropriate terminology for our experiments. So to start, let's start with what is a wave. When we talk about waves in the real world, the first place most people think about is the ocean. But for me, I always think about slinkies and string because whenever you have a bit of string, such as this little bit here, and you shake it, you get these little pulses, and if you continually move it up and down, you get this wave pattern. This pattern is very similar to a sine wave. It is important, but the idea here is that there is a motion, a repetitive motion, that takes on this very distinct shape. This is not the only shape possible. It is merely one possible shape of a wave. This is what we refer to as a transverse wave because the wave, while it's traveling to the right, and you can see that if I restart, notice how it starts here, and it isn't until the wave reaches this point that it starts disturbing and continuing on. The disturbance of the wave from the resting point is perpendicular to the direction of travel, aka it's moving to the right, but the disturbance is up and down. Let's talk about some key points here. The high points and low points have specific names. Specifically refer to the high points as crests and low points as troughs. We can talk about the distance between our crests as our wavelength. Strictly speaking, you could find it between any 2 points you so desire. If you want to go between trough and trough, so be it. You want to do between the upward swing as it passes through the rest, and then the upward swing where it passes through the rest. It doesn't matter. No matter where you look at it, if you grab this ruler here, it's always going to be the same. In this case, a little over 4 centimeters, no matter where you look. The other measurement we typically make is measuring how high it goes. Now, there's 2 ways you can do this. You can measure from the neutral spot, this equilibrium resting spot, to the highest point. That would be referred to as your amplitude, or you can do the distance from trough to crest. This would be known as your wave height, typically more often seen in ocean waves and surfing, but always relevant. Logically, the amplitude, the distance from rest to crest or rest to trough, is half of the wave height because, 2 amplitudes make the wave height. The other very important term to talk about is the frequency. There are many different definitions or ways to think about frequency, but the easiest is pick a point, let's say right here, where my rulers are meeting, and count how many crests pass that point in a second. The number of crests that pass will be the frequency that is measured in hertz, as listed down here. The given frequency is 1.5 hertz, so 1.5 waves pass through this point every second. You can pick any point of the wave. You can measure the frequency of troughs. You can measure the frequency of center points. Inversely related to the frequency is the period, whereas the frequency is how many pass in a second. Period is if I start the timer right now and step through this simulation, how long is it before the next crest passes through? It's the amount of time between repeated points, or the amount of time it takes for one full wavelength to go past. Whatever way you want to think about it, the definition hasn't changed, whatever makes it easy for you. And as stated previously, the frequency and period are inversely related. Specifically, the frequency is equal to 1 over the period, or the period is equal to 1 over the frequency. Final terminology we need to talk about when we talk about waves is the wave speed. In this case, let's step forward a bit. This crest right here is going to move through the wave. If I reset my time, and in this case, it's going to move a certain amount of distance in a certain amount of time, 6 centimeters, in about 1 second, giving it a wave speed of just over 6 centimeters per second. The rate at which the crest travels is the wave speed. Now, there are relations here. There are other ways you can talk about it. That is the basic one. Final term we need to talk about before we talk about simplifying this for us is the media. What media is reference to what is the wave moving through. Now, in this case, the media is a string, but if you're talking in the case of the ocean, the media would be the water. If you're talking about sound, the media is the air that it moves through. All mechanical waves, and what exactly is meant by that is all waves that move through media. It's a bit redundant, but it is a physical moving wave. This is to delineate it from other types of waves that will be discussed at a later time, but any wave that you can see the crests and troughs of, you personally can see, is a mechanical wave. Now, waves themselves are very pretty, very useful, and we can see them move. But typically, there is too much data going on here. It's very hard to see what's going on. So instead of doing a full continuous wave where you're continually moving up and down using an oscillator, this oscillator can be a machine in this case or your hand, oscillating back and forth, creating this wave. Instead, what we typically look at is a pulse. A pulse is a single oscillation. It is a single crest or a single trough. Pulse will also have an amplitude, how far it is from the equilibrium point or the middle. Typically, we'll only have a crest or trough, so we don't talk about the wave height here because there's only one. The pulse itself, we can also talk about its width, how wide the pulse is. It will still have a wave speed because a pulse is a very specific subset of a wave. It'll still have a wave speed, it'll still have an amplitude. The period, the frequency, and the wavelength don't make much sense here. Those deal with continuous waves, but an amplitude, a wave speed are all relevant. So these are the terms you need to know for understanding and doing practice with waves going forward. Thanks for watching. Have a good day.